Live from the Key TV studio to your TV and on the web, it's Homework Hotline. Go to homeworkhotline.tv to ask your math or science questions.
Hi, welcome to Homework Hotline. My name's Dan Scofield. I teach science at St. Bernard's Academy.
And my name's Alysha Simoni, and I teach speech at Alice Birney. Welcome to Homework Hotline.
Yeah, so if you have a math or science question, you've got some homework problem you want to get some help with, I was going to say give us a call, but no, don't do that, because what you can do right now is go right to the live stream at homeworkhotline.tv and type in your question, and we will do our best to try to answer it.
Yeah, or you can just tell us how cool we are. That's cool also.
That's just fine, yeah. We are totally cool. Anyway, I've got some really cool acid and base and acid-base indicator things to play around with in a little bit. We did that on Tuesday. We'll do some more of it. But first, I think Alysha has another puzzle that was, I think, kind of challenging. It's kind of fun.
It was. So this is an excellent lesson on reading your directions, because a bunch of the people here were trying to solve it before the show, and they struggled because they didn't read the words first. So find a value for each icon in the area model below so that it represents the value 144. So the area of this whole area is going to be 144 together. So we have some different, I think that blue was not working fantastic. We have some different items, and they are going to correspond to a number, but we don't know what those numbers are yet. So what we're going to do is solve for them. So automatically I see there's two numbers here for this square, this green square. So I'm going to start there because that's going to be the most simple. And I'm going to give each one of these images a letter so I don't have to draw it. So we'll do P for pretzel, C for chocolate pretzel. We'll do S for pretzel sticks, M for mustard, and we'll do T for salt. All right, so I'm going to start here, and if I want to find the area, I multiply the length times the width, so I have 10 times 5 equals chocolate pretzel. I don't know if you can tell the difference. This one's got salt on it. This one's chocolate dipped. So 50 equals C. So I'm going to put that over here.
Nice.
We already have one area. Now for this pink box here, if you look, these lines are perpendicular right here and parallel, so you know that this, if this is 10 up here, this one's going to be 10 as well. So we have 10 times mustard. 10 times mustard equals 30, because that's the area that's already given. In order to find this, we're going to divide both sides by 10. So our mustard equals 3. Mustard, 3. All right. Now's where it gets a little trickier. So we have 5 times pretzel equals salt, and we have pretzel times mustard. I'm gonna do it like this. Mustard times pretzel equals sticks, except I already messed up here because salt, I was doing T. So this isn't solvable how it is right now. Yeah. This is where the reading the directions comes in. It's very important. So this whole area is going to be 144. So I have 144 as the total area. I already have 50 here, and I have 30 here. So the area that I'm trying to find left, 14 minus 5 minus 3 is 6, is 64 for this whole area. So I still have to break it apart, but I do know this is 5 and this is 3. So pretzel times 5, which is this area, we have to figure out what pretzel is, plus mustard times pretzel, when we know mustard is 3. So pretzel times 3 equals 64, because the area of this one and this one together is going to be 64. So if we simplify this, we have 5p plus 3p equals 64. 5p plus 3p is 8p equals 64. We want to get the variable by itself, so we divide both sides by 8. So pretzel equals 8.
Yes.
All right. Whew. There. I'm going to switch colors just because it makes it fun. Let's do that orange. It was a good one.
Now I think we're home free.
Yeah, now it's a lot easier. So we have the pretzel up here as 8. So we have 8 times 5. I say it one way and then I write it the other. 8 times 5 equals T for salt. So 8 times 5, remember your facts, equals T. So 40. This is another thing too. Sometimes people think that they're wrong or think that that it should be a different number because of the size, but a lot of times they aren't to scale. The images aren't always to scale, so don't worry about that. Just double check your math. To find our pretzel sticks, we have mustard, which is 3, times pretzel, which was 8, equals 24. So our T was salt. Yeah, so our pretzel sticks.
Yes.
Yeah. I think I just wrote the wrong number variable again. Oh, no, I just didn't. Okay. Sorry, I got confused. 24. And then it's always good to go back and check our work. So we have, I'm erasing this. We have 50 plus 30 plus salt is the area of this spot, which is 40. And then we have our pretzel sticks, which was 24. All of this should equal 144. So we have 0 and 4, 5, 6, 7, 8, 10, 14. 144.
It's always good.
So it's all good. If not, you have to erase it and start over.
Great, that was fun.
Yeah.
That tricky part of that one was getting that 64-bit and using it to figure it out.
Yeah.
So,
Yeah.
great.
Figuring that out from your directions.
All right, we're still waiting for some questions. Last time we did some stuff with acids and bases, and we were using red cabbage juice, which comes from the red cabbage, which I boiled and got the juice from. And now it changes colors in the presence of different acids and different bases. And so what happened was it got yellow with a strong base, and it gets pink or red with an acid, and in the middle is neutral. And then, so actually the brain teaser we have that we didn't do last time is that it was, what is the pH of neutral, of pure water or neutral water? And so if you have that, we will say who got it first if you figure that out, and submit it onto the stream. So what is the pH of pure water? You can go ahead and try that on the stream and enter that in, and we'll say who you are and say who got it first. So like we left off last time, I sprayed some window cleaner, which has ammonia in it, into the cabbage juice, and saw what color it was and saw whether it was an acid or a base. And we'll try some other things here in a second, but I'll spray a bunch into there, and it looks like it's going to be kind of on the green side of things. And so that, that's somewhere this way, right? It gets yellow if it's a very strong base. And so it looks like it's somewhat basic. And so, well, how does that work? And I remember we saw up here, I'm going to erase some of your stuff.
Yeah, go ahead.
Okay. This right over here is good. I don't have that much room we have to work with. But we saw before that in water, when it gets, water's always doing a little bit of this, a very small amount of this is happening. H2O, and it's in this equilibrium, and it breaks apart. A small amount will break apart into hydrogen ions and hydroxide ions like this. Just a little bit of it. Really, and this really the correct way to say this is that the hydrogen combines with another water molecule and it makes H3O+. But for simplification, we'll just say this is what's happening. It's happening to a small amount, and anything that contributes to the hydrogen ion concentration is going to be an acid, if it takes away from the hydroxide. Anything that adds to the hydroxide concentration is going to be a base. And so the way some of them might just add hydroxide ions, but ammonia works a little bit differently. Ammonia, if you put it in water, ammonia is NH3. And so if you add it to water, H2O, what it does is it goes, and it's a sum of it. Again, it's in some equilibrium as well. It doesn't completely do this. It goes to NH4, which is called ammonium, and NH4 plus OH minus. And so what it does is it's adding some of it. It doesn't go and completely dissociate to that, but it adds some hydroxide ions to it, and it takes away some of the hydrogen ions. So it's so it makes it somewhat on the base side. So it's a little bit green over here. That's what's going on with ammonia. And ammonia is one of the things you can. Some window cleaners have it. The blue stuff usually has some ammonia in it. You can smell it. It smells very. It's a very distinctive smell. Another thing you can do with this is we can just test a variety of things. We can go. Let's just use these things.
See if we can make a rainbow.
We can make a rainbow, right? So we've got a little bit of green there. This is neutral again, and that's acidic. And so let's see what lemon juice does.
Oh.
And we know lemon juice how it tastes. And so we'll pour some in there and see what it does. Ooh, look at that.
Pretty.
And so that's definitely on the red side of things. So lemon juice is over here somewhere, acidic. And lemon juice is sour. Actually, I think the word acid actually comes from the Latin word that means sour.
Oh, that makes sense.
It makes sense. And so if you have a sour stomach, right, you have something
too much stomach
acid in. So what you do is you might take an antacid, which I've got.
Would be a base, I'm assuming,
well,
to help with your acid.
Yeah, I mean it does. It takes away some of the acid, and so I think if we just put this in, it might take a while to do this one. So I'm going to set it into there, and then we'll mess with it for a little bit, and use a different spoon just because I think that one.
Crush it.
Yeah, we can. Yeah, you want to go crush it. That might take a little bit. We'll see what the antacid does, and we can also see what the maybe soda water does. What's soda water? So this is from a carbonated drink, so we can pour that in there and see what happens. And you can try a variety of things at home too. So if I put a little bit of the water, it doesn't change too much, but I see a little bit of a change. You compare that directly.
Oh, it does. It looks lighter purple.
Yeah, just slightly more on the red side of things. So we'll put it over on this right here. You can kind of see it's just a little lighter purple. So that's our carbonated beverage, and the reason why this happens is because it has carbonated water, carbon dioxide. Forms carbonic acid when you dissolve it in water. And that's what you do when you dissolve carbon dioxide in water. It makes it bubbly, but it also makes carbonic acid, which is an acid. And so you can kind of see it makes it just slightly acidic. How is our?
I mean, it's just turning more white at the moment.
Okay, it's turning chalky.
Yeah.
So what would happen if we went and added it to an acid, maybe?
If we add, would it react?
Let's see. What would happen if we put a antacid into an acid?
Oh, see, that's what I was thinking it was going to cancel that way. You jumped back like there was going to be a huge reaction. I was really waiting for it.
I was hoping it would bubble. Some of these bubble.
He tricked me.
I'm sorry. So we'll see. We can watch that for a little bit. Some of these things take a little bit of time to get done, but this one is turning a little bit the other direction.
Yeah, it's definitely lighter than it was.
Right. Okay, so we have a little playing cards going on. I'm shuffling like I should have shells on it or something like that. But let's try it. I have one other thing here. I have some vinegar in this one, I believe. Yes. I'm careful with that.
Wafting.
I'm wafting it
It's
over.
much safer than
And
just
then
sticking
I'm not
your
showing
face.
this to the camera. Let's see, because we're looking down at it. Okay, here we go. Definitely vinegar is definitely sour tasting, right? So it's definitely over here, and it's acetic acid, and so it makes it's slightly red. So we've got a bunch of products. There's a bunch of other things you can test out, and again, red cabbage is just this this thing. I got this at the grocery store. And I just used half of it, and I got a whole big container of it, a big pot of it. It works great. You can have lots of fun with it.
You know, I've seen you can dye Easter eggs with them too.
Right.
They did a whole I
Right.
saw a whole
Yeah,
presentation.
right. With red cabbage
And
seeds.
shirts and stuff like that.
Yeah, it's one of those natural dyes that you can get. And what's interesting too is you can find acid-base indicators a lot in nature. And so yeah, here we're going to show this one right here. Let's take a look at this. It's a great pattern inside. That when it grew, it was making this pattern. But I love this. This visual of it. But yeah, you can find a lot of the natural things will do this. Like flowers, some of the flowers will be acid-base indicators as well. And I've heard that they'll change colors in different. If the soil is somewhat different, has some different acidity to it. And so I don't know, science fair's coming up, you know, I don't think I've ever seen anybody, I mean, I'm sure it's been done, but it would be a doable project to see if you grew all the same kinds of flowers and you made the soil somewhat different acidity and saw if the flower they produced would be different. But you'd have to start your project pretty early to get it to grow and flower.
And I'm wondering, you'd have to probably get a colored flower to be able to see the difference.
Yeah,
I know a lot of people have done it with like carnations and putting them different soil colors, like adding colors.
Yeah, they could get it, or they put it into the water and they watch it transpiration as it goes up into the petals. But this would be different. This would be how would soil acidity affect the color of the flower. Anyway, so that's some of the stuff we can see with this, and you can see that the other natural things will have different colors and be acid-based indicators as well. So one of the things you could do with this as well is what happens if we mix acids and bases together. And so, for example, I've got this acid. I believe that was this was the vinegar, and this was the base, which was sodium hydroxide, which was from lye, very very strong base. It's what we use to clean out drains. And if I pour a little bit of this into the other one, right away it turns it pretty much.
And if you are into art at all, you know that red and yellow would make orange, not blue.
Right. So it's turning right. It's right. It's doing something else here. But what's going on with this is it neutralized the acid. Just a little bit of the strong base neutralized that acid, and it turned it much closer to the middle there, which would be in the middle of the range. And so if I added some more to it, you can get just little tiny ranges of color with this. Just a little bit more would turn it probably more, more of the green color.
Aqua, yeah.
I can see that this is if you look at that is definitely like a green color.
Maybe do a drop on the white paper.
I wonder what that would do. Yeah, definitely. Anyway, and so you can go the other way around too. What happens if I take something that's slightly, let's see, basic like the one that we had the ammonia in, and we poured a little bit of the acid in it. What will happen to that? And again, it wasn't very basic to begin with, and so it turned it right back into definitely back into purple.
All right, guess we have a question. Let's look. That's for you.
What happens in endocytosis? And this is from, I can't see.
D. Zugan.
D-Zugan asks endocytosis. Endocytosis is when cells envelop things. So they take things into them. And endocytosis is when a classic example I think of that is something like an amoeba. So here the graphic on the screen shows you how it's taking something in. endocytosis. So it's taking something from the extracellular medium, is the area around the cell, and it takes in material from outside. It actually forms the membrane around it. The cell membrane will form a membrane around it, and then it forms a vesicle. The organelle inside the number 3 there is a vesicle, and so it actually it's a way something is taken in by cells. So I know we're studying cells in my biology class. So yes, definitely endocytosis is one of the things that happens. So hopefully that's helpful.
Yeah.
Great biology question. Now we're back to chemistry.
Yeah, I didn't know that one.
That's the fun part. So again, mix an acid and the base together, and they neutralize. What happens is, and actually you can kind of see why if we look at the chemistry behind it. Let's say, for example, we saw the HCl, that was hydrochloric acid. This is pool acid. It's also in your stomach to digest food, and we add the sodium hydroxide, which is that lye, and what it makes is it goes and makes. If you look at this, it makes H2O. And if it's in water, it's going to make sodium plus chloride in water. So it makes salt water. So this is actually, NaCl is just, sodium chloride is just table salt. And so typically if you mix an acid and a base together, it's going to make some kind of salt and water. So that's why it neutralizes. Of course, we'll make neutral water if we had the same amount of each, and salt. So I mean, you could have, depending on the acid you have, it will make a different kind of salt. But that's what we get in this neutralization reaction.
I'm really loving this turquoise color.
Yes, it's really nice. Let's do another thing, which is really cool. And one of the things, speaking of cells, one of the things that's really super important in cells is the cell membrane. We saw how the membrane in endocytosis took in something. Well, cell membranes, you can model a cell membrane with this stuff called dialysis tubing, and it's used for medical purposes as well. We use it in biology classes as well because it's semi-permeable, just like your cell membranes are semi-permeable. They let some things in and they keep other things out. This stuff, larger molecules don't travel as quickly through it, but water and ions will flow fairly freely through it. So an ion, it would be something like the hydroxide ion and the hydrogen ion. Those will flow through this membrane pretty easily. And so what we can do is we can watch. I've made a couple of model cells with cabbage juice, and it looks like a little bag of cabbage juice, and inside a semi-permeable membrane. And so we can watch what happens to them with.
Like little sausage links right now.
And this would be diffusion. So diffusion, it will diffuse through this. So I'm just going to make a clear bath of, let's start with the sodium hydroxide. Let's start with the lye. And again, this is drain cleaner. This is straight drain cleaner.
Ask your parents before you get in there,
yes,
though.
definitely don't want to. You want to definitely ask your parents before you play with this stuff. So drain cleaner, and so it just still should stay clear like this. And let's take one of our bags of our model cells, and we'll pour it. We'll just set it in there. I want to be able to lift it up
I'm
again.
excited. We just gotta hurry because we only have a couple minutes left.
Okay, and that should clear up in a second, so we should be able to see it. I think I put just maybe too much of it in there. I got a little over enthusiastic about how much I put in there, but it'll happen faster this way.
You really wanted a reaction.
I want a reaction. Okay, so we'll look at that in a second. You can see it is doing something, and then in this one, let's put some of the hydrochloric acid. This is fairly dilute, so it's not gonna hurt. But I got it on my hands, and I'm gonna put a little bit more water in here just to fill it up a little better. And so you can see that the liquid itself is not changing colors here. It's just, and then I'm going to put this into there.
Ooh.
You can always, I think maybe it's not leaking. It's just, you can see it's changing a little bit of color.
You know, there might have been like a little liquid in the folds at the end.
Right. I'm going to put that on that side and that on that side. And now in the middle, let's just put use regular water just as our control, and put a bag in there. I know the bags ideally would be all the same size, but
Let's peek at these a little real quick before we have to go. But there will be more science next week on Tuesdays and Thursdays at 4:30. So tune back in.
Yeah, so you can see. Yeah, you can see that
it's like yellow.
the hydroxide ions were able to diffuse through the membrane and get to the cabbage juice, and the other side, the hydrogen ions, were able to get through also. So
see you next week.
Great. Bye.